For question F, we have to use Gram-Smith process to construct an orthonormal basis from U1, U2, and U3. So we will have, let's say I have Z1 is equal to U1 because we have here is U1, U2, and U3. And Z2 is equal to U2 minus the projection of U2 onto Z1. And we have Z3 is equal to U3 minus the projection of U3 onto Z1 minus the projection of U3 onto Z2. In the slides, you will see that I just replaced the symbol U and V, but here is U and Z because we have U here, so I just keep the same like this. So next, when you know Z1, G2, and Z3 already, you just need to find E1 is equal to C1 divided by the length of Z1. Then E2 is equal to Z2 divided by the length of Z2. And E3 is equal to Z3 divided by the length of Z3. And E1, E2, and E3 is the orthonormal basis. So let's calculate it together. We have Z1 is equal to U1 and U1 is equal to 1, -1, 0, right? And Z2 is equal to U2. U2 that is 1, 1, 0 minus the projection of U2 onto U1. So we have is equal to the dot products of U2 and Z1 divided by dot products of Z1 and Z1 multiplied by Z1. This one is calculate the y-hat like question D, the y-hat here. The projection of U2 onto Z1. So we will have here 1, 1, 0 and minus the dot products between U2 and Z1. Z1 is here. So U2 and Z1. So we will have Z2, U2, and G1. So we have 1 multiplied by 1 plus 1 multiplied by -1 plus 0 multiplied by 0 divided by the dot products of Z1 and Z1. So Z1 and Z1 we have 1 square plus -1 square plus 0 square multiplied by Z1. Z1 is 1, -1, and 0. So we will have here is 1, 1, 0 minus 1 minus 1. So this is 0. So we have 0, 0, 0. So we have Z2 is equal to 1, 1, 0. This is Z2. So this is Z2. And we have Z1 and Z2 already. Now we calculate Z3. Z3 is equal to Z3 minus the projection of U3 onto Z1 minus projection of U3 onto Z2. So we have is equal to the dot products between U3 and Z1 divided by the dot products of Z1 and Z1 multiplied by Z1 minus the dot products between U3 and G2 divided by the dot products of G2 and G2 multiplied by G2. Okay, and we have G3 is equal to sorry, this one should be U3. We have U3 is equal to 0, 0, 1. 0, 0, 1 minus the dot products between U3 and Z1 is make it smaller. U3 and Z1. So we have 0 multiplied by 1 plus 0 multiplied by -1 plus 1 multiplied by 0. So it's equal to 0. Divided by Z1 dot product of Z1 and Z1. That is 2. Right? Multiplied by Z1. Z1 is 1, -1, 0. Minus the dot products between U3 and Z2. U3 here, Z2 here. So we have it is 0 multiplied by 1 plus 0 multiplied by 1 plus 1 multiplied by 0 divided by the dot products of G2 and Z2. So this one, so we have 1 square plus 1 square plus 0 square multiplied by Z2. G2 is 1, 1, 0. And here we see this one is equal to 0. This one is also equal to 0. So we will have 0, 0, 1 minus 0, 0, 0 minus 0, 0, 0. So the final answer is 0, 0, 1. So we can find the G1, G2, and G3. So let me write it here again. Z1 is equal to 1, -1, 0. Z2 is equal to 1, 1, 0. And Z3 is equal to 0, 0, 1. Okay. And now we can find E1 is equal to Z1 divided by the length of Z1. The length of Z1 is let me write it here, equal to square root of 1 square plus -1 square plus 0 square, and that is square root of 2. So we have here is equal to 1 divided by square root of 2 -1 divided by square root of 2 and 0. What is the length of Z3? The length of Z3 is equal to square root of 2 also. And the length of Z3 is equal to 1. So we have E2 is equal to 1 divided by square root of 2, 1 divided by square root of 2, and 0. And E3 is equal to 0, 0, 1. So we have the set orthonormal basis is E1, E2, and E3. So we have this set is 1 divided by 2, -1 divided by 2, 0, 1 divided by square root of 2, 1 divided by square root of 2, 0, and 0, 0, 1. So this is the answer of the question F.